Hello guys! Today in the lesson we will consider the algorithm of multiplication of fractional numbers. So what do we need? To multiply fractional numbers? Let's start with an example. If we need to multiply 1, 2 by 1, 3, what do we do? In multiplication and division, we don't need the common denominator that we're used to. We just need to remember the rule that we multiply the numerator by the numerator and the denominator by the denominator. The result of this multiplication is a fraction of 1. Sixth, guys, in order to remember which rules to use for which actions, you need to remember one very important observation or important rule. Always two actions that compensate for each other have the same rule. What actions am I talking about? If I take the action of addition, then the action that compensates for it is subtraction. And then addition and subtraction will always have the same rule. If I take the action of multiplication and the compensating action of division, then the same rule will be the same for these two actions. So in order not to get confused about the algorithms for fractions, you need to keep in mind that when adding and multiplying fractional numbers, we always need to find the least common multiple, and that's very important. And when we need our fractions to multiply or divide, I'm going to look at the numerator separately. And I'm going to look at the denominator separately. Multiply in our case, multiply the numerator and multiply the denominator. So, let's take another example where we need to multiply two fractional numbers. So we need to multiply 5/6 by, let's take 1 9. What am I supposed to do in this case? The rule of thumb is that I have to multiply 5 by 1 and 6 times 9. It's very easy to do the math. 5 times 1, that's 5. And 6 times 9, that's 50. 4. And that will be the answer. So our answer is going to consist of multiplying of our numerators. The product of our denominators. This is the rule you should use when multiplying our fractional numbers. Guys, the only rule you need to pay attention to when multiplying fractional numbers is the rule of reduction. So what do we have to reduce and why do we need to do it? If I want to multiply the next fractional number, then by our rule, I have to multiply the numerator by the numerator and multiply the denominator by the denominator. The result is that I get the following fraction. 3 times 4 is 12, and 16 times 9, that's 144. According to the rules, we must write down the irreducible fraction in our answer. That is, we must pay attention to our answer and consider whether we can reduce the given fraction. 12 and 144, of course we can reduce. So 12 and 144. What do these two numbers divide by? Of course they divide by 2, they divide by 3, but let's go in order. If I divide 12 by 2, let's say, and I divide 144 by 2, I end up with 6. 72nd. But the 6 72nd I can still reduce. I can immediately divide by 6 both the numerator and the denominator. The result is 1. 12th. Of course, I could immediately divide 12 144ths by 12, both numerator and denominator, but if you do it consistently, it's not a mistake. So, when multiplying fractional numbers, you multiply the numerator by the numerator and multiply the denominator by the denominator. But what's the rule I was talking about? The point is that we need to represent the answer as an irreducible fraction. And you can see that there may be some difficulties in the reduction. So I'm going to give you an easier way. So 3/16 times 4/9 equals 4/9. And the algorithm is the same. 3 I multiply by 4 and 16 I multiply by 9. But what's unusual about this case? I'm not going to, guys, multiply 3 by 4 and 16 by 9. What am I going to do? I'm going to see if I can reduce the numerator and denominator right away. We'll reduce the numerator and denominator in pairs. What do I see? 4 and 16 divided by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4. Three and 9 can also be reduced. 3 divided by 3 is 1, and 9 divided by 3 is 3. This leaves me with 1 times 1 and 4 times 3. Multiplying the numerator by the numerator, I will have 1, and the denominator will result in 12. As you can see, I got the same answer. The only thing is that in the second case, I immediately reduced the numbers while they were small and got an irreducible fraction. Of course, we will work on this algorithm in the next lessons. And that's all for today. Goodbye, and see you again.